In this lesson, you will be applying the triangle sum properties. And first of all, we need to review what we can do to classify triangles by their sides and by their angles. So you can classify a triangle by its sides, saying it is equilateral if all three sides are congruent. The triangle would be isosceles if only two sides of the triangle are congruent. And finally, a triangle with no sides of the same length is called scalene. We can classify triangles by its angles by saying it is acute if all the angles are less than 90. It is right if there is one right angle in the triangle. And it is obtuse if there is at least one obtuse angle. In the next example, see if you can try and classify the triangle given. So looking at this triangle right here, we want to classify it by its sides and by its angles. Okay, so if you actually took a ruler and paused the video and measured the side lengths, you would see that two of the sides of the triangle are congruent, and a protractor would lead you to see that one angle is 70 degrees, and these two bottom angles are 55 degrees each. Since two of the sides are equal, classifying the triangle by its sides, we could say it's isosceles. And classifying the triangle by its angles, you would see all of the angles are less than 90, so it's an acute isosceles triangle. Classifying a triangle using the coordinate plane, we have to use the distance formula to find the side lengths. So using the distance formula, you can calculate the length of OP. So OP is this side right here. So we're finding the distance between the points 0, 0 and negative 1, 2. So using the distance formula, the length of OP is the square root of negative 1 minus 0 squared plus 2 minus 0 squared. And when you work that all out, you get the square root of 5, which is approximately 2.2. So we know that this distance from here to here, or the length of that side of the triangle, is about 2.2. To find the length of another side of the triangle, for example, OQ, we would find the distance between the points 0, 0 and 6, 3. So use the distance formula to calculate that. Pause the video, and then I'll show you the answer. Using the distance formula, you should have gotten OQ is approximately 6.7, so the square root of 45. Finally, calculate the last side length of the triangle, PQ, and use the distance formula. The length of PQ is approximately the square root of 50. Or it is the square root of 50, which is approximately 7.1. So now looking at all of these side lengths, we can definitely classify this triangle by its sides, and since none of them are equal, we would say that it's a scalene triangle. So we already know that it's scalene. Next, we want to classify it by its angles. So first, let's check for any right angles. So we're going to see if there's any right angles here by seeing if any of our lines are perpendicular. And remember, how can you tell if things are perpendicular? Well, their slopes would be opposite reciprocals. So let's check the slope of OP, which, remember, slope, you take the difference of the y values and then the difference of the x values, and you divide. So going back, we're looking at O, which has a coordinate of 0, 0, and then P, which has a coordinate of negative 1, 2. So let's find the slope. So the slope would be 2 minus 0 over negative 2 minus 0. So the slope of OP is negative 2. The slope of OQ, if you go back and look at the picture, we would take 3 minus 0 divided by 6 minus 0. and you would get positive 1 over 2. Notice the slope of OP, which I can rewrite as negative 2 over 1, is the opposite reciprocal of positive 1 over 2. So if you have an opposite reciprocal slope, we know that that means the lines are perpendicular. So since if we multiplied the slopes together, so the product, this is just another way to show this, the product of the slopes, which is negative 2 times positive 1 over 2, is negative 1. So we know that OP, that side of the triangle, is perpendicular with OQ, the other side of the triangle. Therefore, and we can say angle POQ must be a right angle. So if we go back and look at our picture, angle POQ is a right angle. So not only can we say this is scalene, the triangle is also a right triangle. So classifying this, it is a right scalene triangle. So right scalene triangle. Here's just a quick exercise for you. I want you to try and draw an obtuse isosceles triangle and an acute scalene triangle. Here are some examples. On the left, triangle ABC is an obtuse triangle because this angle here is greater than 90, and it's isosceles because 2 of the sides are equal. On the right, triangle PQR is an acute scalene triangle because none of the sides are marked congruent, and that angle might look like a right angle there, but let's say it is 88 degrees, something less than 90. So all 3 angles are less than 90. In this example, I want you to try and draw the triangle by plotting the points on a coordinate plane. So 0, 0 is point A, 3, 3 is point B, and negative 3, 3 is point C. When you graph this, you can hopefully identify that we would have some type of relationship with the sides. That's not what the picture really looks like. You have to actually graph it. That's what I want you to do. But you would be able to see that there is a relationship with the sides there. Okay, so I want you to pause the video. I want you to try this on your own. See if you can figure out if this is an isosceles acute triangle, an isosceles right triangle. See kind of how you can classify it once you plot the points. So remember, you want to calculate the distances to verify which sides are equal. So we would use the distance formula between the points. And then you also want to check for any right angles. That was the next step. So use the distance formula, check for right angles. Okay? The way we check for right angles is by testing the slopes and seeing if any of them are opposite reciprocals. All right, so go ahead and do that. The answer is that triangle ABC does in fact have a right angle, so it's a right isosceles triangle. Okay, great. Okay, the major theorem, so the meat and potatoes of this lesson, is the triangle angle sum theorem. You might have learned about this before, but in any triangle, so I'm going to draw a triangle ABC. In any triangle, the sum of the interior angles, so the angles inside the triangle, is 180. So the sum of interior angles of a triangle is 180 degrees. So what we would write for this example is that the measure of angle A, so the measure of angle A, plus the measure of angle B, plus the measure of angle C, all equals 180. Now this is a word you haven't heard of before, corollary, or maybe you have. But a corollary, similar to a postulate, is just something that comes directly from a theorem. It's just kind of an obvious thing that comes out of a theorem. So the corollary of the triangle angle sum theorem says, if you have a right triangle, so I'm just going to say this and draw a picture. If you have a right triangle, then you know that those other acute angles, so in this case A and B, those acute angles are complementary. They have to add up to 90. And then altogether, the whole thing would equal 180. So the corollary just basically says that angle A and angle B, that looks like an LA, angle A and angle B are complementary. So they add up to 90 degrees. So that's the corollary. The exterior angle theorem also comes from the triangle angle sum theorem, but I'm going to draw a picture for you and then tell you what the exterior angle theorem says. So given this visual, you have triangle ABC, and then you have this exterior angle. You have some angle outside of the triangle. Well, the theorem says that this angle, the measure of angle 1, is always going to be equal to the sum of the two angles in the triangle that are not adjacent to that. We call those the remote interior angles. So those two angles there are the remote interior angles. Okay, so the measure of angle 1 equals the measure of angle A plus the measure of angle B. All right, that is the exterior angle sum theorem.